Okay, so now it's recording, and I just typed in the command Grasshopper in my command line. After it loaded this plugin called Grasshopper. Rhino, McNeil Associates, they have this thing about naming all their plugins, and then all the third-party developers that develop plugins name all their plugins after animals. It's really kind of silly. So we have things like Grasshopper, and this one's Kangaroo, this one's Honeybee, Wasp, Ladybug. This one's Silkworm, Rabbit. There's crazy, silly things. So anyway, what Grasshopper does, you can see there's an interface here. There's a bunch of tools along the top. Then there's some sort of artboard down below. But what it does is it allows you to write script or code or program, but graphically, right? So it's like a node-based graph um, where you can basically do things that you would do by writing code or script, but without actually having to write things out. So the way I sort of look at this is you're sort of building the recipe or the mind map to take something and how do you put this? To sort of generate geometry, and then you can start to plug in geometry and change parameters, and everything sort of updates. Okay. So let me just show you what this maybe looks like here. Let me go to that directory and see if I have some of the relevant files still. Let's see, home, document. There should be a teaching here. Let's try this one, why not? Demonstration photos, we have Illustrator, PDF. And let me just find, let's see, DTLV, site details, concepts. Yeah, maybe I have a DTLV. That'll work well. All right. So I'll just go ahead and open up what looks like yet another sort of downtown site model of some sort. Maybe this is incomplete, actually. Let me just double check and see if there's another one in here that's a little more complete. Model for drawing extraction, site ID. Let's see what I have here. Looks like a rather big file. Let's see what we have. All right, well, I definitely have some geometry in this one. Oh, I see. Somebody was doing some sort of test in here. All right, so we have a section perspective being cut with a clipping plane. And a set of plans being cut. Okay. That's not what I was looking for. Ay, ay, ay. Okay, give me one more minute here. This is well, my goodness. Let's see, list. Let's go with details and see. DTLV massing demo somewhere. Okay, I'll go ahead and use this one. Let's see what this one looks like. Please work. Okay, anyway, I have something like this, and you can see that I already have a sun path for a particular time of the one day of the year, it looks like. For that diagram. Let's see here. Fortunately, I've actually made layers and labeled them so I know what things are. So that's always a good thing. Always a good day when that happens. All right. Yeah, all right. So with that said, let me go ahead and open up this other document and see what we have here. Sun path. Okay, I'll deal with that in a minute. That escape example. Let's try that. All right, so this is what a Grasshopper file looks like. It's basically just a node-based visual programming tool. So, you'll have like something that like a widget here that contains a set of geometry from Rhino, and then that becomes the input or the ingredient for this widget, this tool. which gives you a bounding box of all the materials that you just a box around all the ingredients that you just plugged into the left. Gives you that bounding box. We can plug that in as the next ingredient for this tool. It then gives us like an X dimension and a Y dimension of the box. We populate that with a grid of points. Then we give it a value. Let's say that grid of points a value going from white to black. Then we assign some sort of color values to those. And let's see what we have here. Say clear values. I'm just going to set multiple geometries. I'll select all this stuff that I have in Rhino. All right. And now I have a height field of lines in my site. So if I had some sort of graphic, let's say a heat map, or I started to, in Photoshop, take the map of Las Vegas from above and start to like map with gradients, like where I have more or less noise or smells or traffic or whatever, then I could plug that in here and then create this visual representation where you can see that, I don't know, for whatever reason, I've picked this gradient. Let's see what kind of gradient we have here. Presets. I could go from red to blue. Or let's see, red to green, or various shades of green. I could do the whole color wheel, it looks like. That almost looks like someone's birthday party or something, decorations. Let's see here. Yeah, maybe I go maybe red to blue. And so now I can start to see the extremes. Reds and blues are going to be the most extreme. What's interesting is that at a certain point, then I can sort of bake these back into Rhino and then take them into Illustrator, and they'll all be colored in a particular way. So really quickly, without digging too much into this, but again, just to say, each of these nodes is like it's like almost like correspond to like hitting one of these tools in the toolbar in Rhino, right? So for instance, if I found a tool here that said draw a bounding box around all the objects I have selected, right? I'd click that tool, and then in the command line, it would ask me for the ingredients. It would say, select any geometry that you want, and then hit enter when you're done, or right click when done. And then it would actually, as an output, give me a box, right? Same with when we extrude something, right? The input is a curve, the output is an extruded surface, right? So step by step, it sort of does this procedurally. Now I can go back and change the ingredients, or I can change any of these parameters, like how granular I want the information, how many steps in between the minimum, maximum, right? I can go ahead and change that, make it more or less dense, more or less readable. I could begin to change the multiplier for how much height the tallest things are and how short the shortest things are. Normalizing between 0 and 1, or whatever those minimum maximums are. And then I assign colors to them based off of their height by sorting them by height. Okay. So that's that. And right after this demonstration, I can go ahead and post these examples on line, or send them to you. And in that way, if you want to experiment with them anytime, you can, in this studio or elsewhere. So that's the Datascape example. There are plugins for Grasshopper that actually take open map information, and you can try to start to, but it's kind of buggy how it works. You're relying on a bunch of third-party information that isn't always accurate, and but you could try to actually map data in without having to sort of manually place things. But again, you're sort of trying to rely on open source stuff that sometimes is accurate and other times isn't. Let me go ahead and close this. The reason I pointed out things like Ladybug and Honeybee and some of these other things, Honeybee, Ladybug. Ladybug's an interesting one because what it allows you to do is import weather files from like any municipality or airport, and then plug those things in and then begin to map that stuff as well. So it lets you visualize the weather data. You can do a sky model. You can do a cumulative sky matrix. You can calculate sun paths. You can calculate radiation. You can there's a windrows, based off of the wind data. You can do a set of environmental analyses off of this. It's pretty complex. But here, let me show you some examples that I again can post and give it to you to make available to you. If you want to experiment with them, feel free to. Let me show you this one, for instance. I just saw it over here. Let's see, in 2021, sun path, direct radiation. Let's do sun path. And it looks like I have an old version of this. I might need to sort of update this. Might still work, I don't know. So anyway, what this is going to do, oh, it's interesting. Look, it's already doing it. For a certain time of the year, it's already mapping out where I get the most solar radiation striking all these surfaces and where I actually have shadows. So I'm getting some red areas that are less shaded all throughout the year, getting areas that are more shaded throughout the year. Obviously, north parts seem to get more. Tighter corridors between taller buildings get more shade overall on average. And that's what this part of what this thing does. It's kind of interesting. Oh, I see. No, that's part of my that's something I baked in. Hold on, let me just get rid of that. All right, here we go. Now you can see my site. I had that turned on. It's something that it's the next file I'll show you. You can actually generate those things. So let's generate a sun path. First of all, I can toggle this on true. And what it's going to do is it's going to tell me to download a specific weather file. It takes you to this website on your browser where you can go all over the world and try to find the closest, most accurate weather data for your location. I'd probably go to formerly McCarran, now I guess Harry Reid International Airport, LAS. You can download these. I'll go ahead and download it. Why not? Sure. All right. Let's see. I'm going to go ahead and turn that back to false. I'm just going to go back because this takes a while to sometimes to generate. There's like multiple gates so that you can sort of turn true or false. So if you give it some information up here, it's not going to like take 10 minutes just to try to calculate everything downstream before you can sort of fix or change something by accidents. Let me just see if this actually works. Okay, so it's directing me to then point it to this weather file, the weather data, which was a long time ago, apparently. Okay, well, I'll just give it this one. All right. Okay. And so now it's doing several things, right? First of all, I can tell it exactly where north is relative to my model. So I turned my model so true north wasn't in the y direction, but I could model an x and y along the street grid. So this is where I can compensate for that and tell it that net north is actually 22.5 degrees counterclockwise to the y position here. So you can see where north is on my compass. And then it begins to give you multiple sun paths, right? So for instance, this is giving me, well, of course, this is for my, or sorry, for my, for our, gosh, why can I not think today? Our latitude. All right. So, all of these angles and things like that are based on your latitude, right? So the lower, the closer you are to the equator, the higher these things get, and the closer you are to one of the poles, north or south poles, the lower these things get, and oftentimes then you'll even get, full day of sun or full day of dark, right? So, by giving it the weather file, it also gives it our latitude, our exact location, and we can also tell it what location we actually want the sun to be. So here we have adjust the time, hour, day, adjust the scale of the sun and paths. So let's see here. For instance, I could tell it that it's see if I can scoot this around. You can see that sun moving around, right? Just a bit. And of course, I could tell it that instead of being on June 21st, we're going to go to the winter solstice. Oh, wait, no, I guess that's January. Here, we'll go to the winter solstice, December, right? And then we can track it throughout the day, right? So you can begin to sort of give it hour to hour, sort of, like showing exactly where the sun is, just like in Revit, right? So, I mean, again, I realize that these tools seem a little superfluous and maybe a little more involved than you necessarily want to be. And looking at this data, because Revit just sort of, it's something you can just toggle on down below in the settings. It's really useful. Okay, but I just wanted to show you that there are these tools. And then if I wanted to make a diagram of these things, I could simply in Grasshopper, I can bake different instances of these geometries to Rhino in different layers and then export them from Rhino into Illustrator, just like we did the other day. Okay. One other I just wanted to show you. Let's see. Is we'll do that. Oh, went all the way up there. Okay. Home, documents, teaching, and there we go. Direct radiation. So this is an example that gives us direct radiation readout. And what's interesting about this is we can map this onto your site, onto the entire city grid if you wanted to. Or you could bring in, let's say, your planar compositions or any kind of massing studies you're doing for your design and start to see how much of it's in shadow. Let me show you what this does. Let me make sure all of these are set to false before I go, because this can be a heavier file. False, false, false. Okay, so we can sort of set gates iteratively as we go. We've already downloaded a weather file. So here I'll just go ahead and turn this to true and go ahead and point it to that weather file again. There we are. Now we can select the test or ground surface. In this case, I'll just do that. I'll just let's see, set one poly surface here. And let's see if I can actually just make one while in this tool. Let's see. I'll just do that. Yeah, okay, set one. And I'll go ahead and just select it. Surface. All right. For our purposes, I'm just going to turn off these blocks. They're not really casting too many dramatic shadows anywhere. Then I'll select the context and building masses. That's important because those cast shadows. You can select which of these or all of these that you want to actually have an effect on the solar geometry. All right. Okay, so I've done that. I've basically brought in and referenced some of this geometry in Rhino into this calculation, this script. North has already set something. Grid size I've set to 10. I'll keep it at 10. Distance from base. Okay, toggle. Okay, so what it does is it basically takes the weather file and then it begins to look at all the information from it, including putting together a cumulative sky matrix. So it looks at all the daylight hours seasonally and the averages seasonally. And then what you can do is you can, in a more granular fashion, sort of pick out times of the year that you want, right? So you have a minimum sort of beginning dates and end dates. You can go from January 1st all the way to December 31st if you want, just do a whole year annual average. Or you could say, well, I'm just really kind of interested right now in, how bad will it be in the summertime? That's the worst case use, right? But anyway, I'll just show you what this looks like annually, and then maybe we can change those settings. So let's go ahead and let it calculate the sky matrix. This is where it comes up, where you have to download and install also the Radiance plugin from the Department of Energy, Berkeley Labs. So yeah, again, these tools are a little involved. Like I said, in past years, we used these tools. Last year, we had a hard time getting them to work on everybody's machines. Maybe they're just a little outdated now, which is unfortunate because they really are useful. Let's see, where are we? There we are. Okay, so it's done calculating that. And then what we can say is, please please go ahead and place a map. Let's calculate the map and all these values now onto the ground and calculate how much radiation. So what it's doing is it's seeing where light's coming from and how much of it's there based off of a calculation of seasonal, I guess the seasonal variety of the sky matrix. So, we sometimes different seasons have more overcast days than others, or have tendency for more particulates in the air for reflecting and diffusing light. But suffice to say, once we do that, let me just hide this surface really quickly, right? Then we get something that gives us, we set a 10 by 10 sort of grid size. So that's how granular of information we're getting. Now let's look at that and let's turn this back to false. And let me just set this now to something different. Instead of this, let's give it May 1st to September, or no, August 31st or whatever. We'll hit true. Okay, so now we're just going to calculate, let's say, some of those summer months, May, June, July, and August. Let's see what it does here. It takes a minute for it to calculate. Let's see what it does. And then we can compare that to sometime today here. We can compare that to the winter, right? So again, this can be really handy if you have like massing and you're trying to see, well, where do I actually have shadows? Do I have any shadows in the summertime? If so, then that's an opportunity, or where do I have the hottest, brightest spots? Those are spots that you actually have to mitigate for, right? So in the summertime, there's very little shade, right? Not a big surprise, honestly, right? I suspect that would change in the wintertime. So let's do that. I'll turn this back to false and change this again. We can always, again, you could always make adjustments to your massing or your architecture and then rerun the analysis and sort of see, if red turns to blue in some cases, or red is, now on a screen instead of on a floor plate or something like that, right? So let's go with November 1st to the end of January or something like that. And set this back to true and see what happens then, right? So each time we're doing a different calculation. And again, the more granular you get, the more you can see, right? An annual average doesn't give you too many surprises. I think we already made the observation that our site is very sunny, has a lot of south exposure, even has some west exposure and east exposure. And unfortunately, doesn't have a lot of north exposure unless you go taller or higher than its neighbor, which it seems likely though. Let's see, right. So in the wintertime, you can see that we are getting more shadows. So, oftentimes the darker blue means that that area is in more shade than any of these red areas where there's probably not much shade at all, except when the sun goes down or right before it rises. This isn't our site. This is somewhere else. I think this is along, I don't know, can't remember, 3rd Street maybe. Beats me. All right. So yeah, anyway, those are those files. And like I said, it's not something that you would just look at and pick up and it's really intuitive. It's not really intuitive at all, so much, right? So let me go ahead and turn this back to false, turn this back to false, turn this back to false. Oh, actually, and then what I'm going to do really quickly is I'll say set multiple B reps for this, and I'll select the ground. And maybe I'll also select this. I want to maybe map it on this solid, right? Let me go ahead and turn these back on now. Each time. Come on. There we go. Radiance doing its work. Thank goodness it's calculating the sky matrix for us. All right, taking just a minute. It's a lot of numbers to crunch. Let's see here. And now we'll set this one back to true as well, and we'll see this readout. We'll see how it reads. Yeah, okay, it's thinking. It's just got to take a while. if you think about it, it's got a lot of data to crunch and average, but it's doing it for each little 10 by 10 point on the grid along this city model that I have. So, it can take a while. Um, right. So now you can see as well, interestingly, right? You can see that, the south exposure of this building, a significant portion of it is never gets shade. There are portions of it that do, and they're in the winter time. The west side has fairly decent amount of shade. And then it didn't even calculate the east side. I'm not sure, or maybe it did, but it's like this. It's just sort of it's just to get some morning sun, and afterwards it's largely untouched. And then of course the north side is nice and blue, right? So not a lot of huge surprises there, but it can be handy, particularly as you're developing overhangs, louvers and things like that, screens, to sort of test these things and say, well, I'm assuming this will work, but does it? Let's test it out. Instead of having to draw this geometry in section, this will do it for you and do it on a seasonal average basis for you. So it's kind of handy to sort of see. Could be that if I do overhangs, um, you know, the sun is actually lower in the winter time, right, in the sky. And so maybe we actually do get some of that winter sun in and actually help us heat up some things inside versus in the summertime when everything's sort of bounced and shaded. If we used a horizontal shading system, louvers or baffles, screens, brise soleils, etc. Right. So anyway, I'm actually surprised by how much blue I have on the west side there. Interesting. Also keeping in mind that true north is actually, you know, is more like in this direction. Oops, not ortho. Is more in that direction. So yeah, I guess it's northwest. Interesting. I know why also, because in the wintertime, the sun's lower when it's in the western sky, and so we are getting more shade. As in the summertime, I guess that I would highly suspect that would change pretty dramatically. We would get some west sun, northwest sun as well along this face. Certainly, this would provide us some shade in places, but it's kind of limited in its size compared to this big west facade. Anyway, was there anything else? Oh, I was just going to say, I made those gradients in Illustrator and showed you how. Um, but again, you can always map these things in Rhino and then bring them out as well, using the Make 2D if you need circles or shapes that you want the line work for. But Illustrator is pretty easy at making squares and circles and little random symbols and things like that. Map symbols like pins and things like that we now use on online maps. So I would say Illustrator is probably your tool for choice and sort of bringing in the Rhino geometry and renderings and line work, and then just prettying it up when mapping the information on it. Right, that was a lot to digest. No, a heck of a lot. And like I said, the sun path and seeing these things. I mean, I could just as easily without seeing maybe not getting like an average over time, but sort of hour to hour, minute to minute, I can see where the sun is casting shadows and where I'm getting radiation, where I'm getting shade. In Revit, just by simply clicking it on, it's a lot more responsive. So I would say, there's something interesting about maybe doing some shadow studies in Revit at key times of the year and day. And it's a lot easier to bring that out, those isometrics out. It's already set up to just be an axon, and you can just bring out the image. Okay. So I recommend doing your sun studies in Revit anyway. That's also really quickly just to say that we can actually, let's say, put this on rendered mode. I'm going to go ahead and see, where's Grasshopper window? I'm going to go ahead and close Grasshopper. But right now we just have this sort of soft shading on in rendered mode. But if I go to, probably there used to be render tools over here. Let's see, these are just layers. Let's go to properties and see if there's, no, okay. So what I can do is I can go to the render pull down and go to render properties and see a bunch of render settings here, if it ever pops up. I don't know if you guys can hear the fan on my processor right now. My laptop was like, sounds like it was getting ready to take off as a helicopter or something, when I was doing some of those calculations in Grasshopper. But what I can do is actually turn the sun on and get some direct sun and direct shadows. Let's see, view. Show shadows only, sun, skylight. Let's look at the sun settings here. And again, we can tell an exact location like Las Vegas, Nevada. We can say if we have daylight savings, we can give it the time of day, time of year, time of, let's see, to basically set the sun. Or we could do manual control and just change its azimuth and altitude with a couple of diagrams here. I'm just going to go ahead and turn off manual control and turn it on. Let's see what happens when I don't necessarily see a big difference here, which is kind of odd. Oh, yeah. And so now I can render this not only with the staff shadows, but with the shadows here on Rhino as well. They're not quite as crisp as Autodesk Revit, Revit, yeah. But you can, again, you can see that relationship. And of course, if I just wanted to, let's see, let's type in sun, let's type in sun. See if that gives us just the sun settings. Yeah, it did. Right, so now I have sun settings over here. So now I could basically, let's see, let's change the time from, let me move this over, 10 a.m. to, I don't know, sometime in the afternoon, right? And so you can see the, shadows are fairly predictable. Okay. So just like in Revit, you can do the same things in Rhino. It's just a less intuitive way of doing things. I think Revit's really made to sort of help people look at these things and understand them while making some of these decisions. Rhino has these things, in spite of the fact that people use Rhino for all kinds of things, shipbuilding, jewelry design, anything that needs freeform geometry, Rhino's really good at as well. So whereas Revit's terrible at. So think of Rhino as the sort of freedom with geometric modeling, and Revit is the tool that that wants to think everything's a building, right? And if you can go back and forth between the two and sort of take advantage of each strengths, they're a pretty nice set of tools. Okay. I was recording this, so again, it's there. If you want to play around with these things, feel free. I am going to stop sharing and stop recording. First, well, I guess first, are there any quick questions about this? I know that was an awful lot to digest.
Yeah, I was gonna say this is all like super, super new to me. So
Like mine.
yes, my mind is blown and fried. But obviously I'm gonna rewatch this and give it a try. But
Think about it maybe later when you have free time, if you ever have free time, right? I mean, to me, I think the important thing is I just showed you that there's certain tools, if you want to get a little more granular than what Revit shows you, you could actually do them, and I'll make them accessible to you guys. However, I would just say that, these tools, I mean, you have a similar set of tools in Revit. They're much easier to use. We've already started to use them. Just use them in Revit as you go, right? And
okay.
I think you'll have a much easier time. So if you want to do some sun, some sun
Yes, I'll
path
definitely
diagrams
give
in
that a try.
Revit, just, again, you know how to do it. You set it up in Revit, turn it on, set it to the time that you want, and then you can export it out as a JPEG or a PNG, right? And so, there's
Okay.
ways of, yeah. All right.
Okay.
What else? Anything else before I stop recording this little quick session? Okay. If not, then I'm gonna turn off